What's up everyone? Welcome to another Joel Arsenault YouTube video. First off, a huge thanks to everyone who has wished me a speedy recovery on my injury. For those of you who don't know anything about that, I was out riding my X2 and I injured my knee. I'll talk about it a little bit more at the end of the video, but for now, we're going to talk about the KRASH KV997. If you do a search on the internet for this thing, you'll find a big group of people who love it and an even bigger group of people who hate it. So, is it really the engineering disaster that everybody says it is? Is it really as poor quality? And yeah, what do I think of it? I'm gonna be tearing this down, taking a good look inside, seeing if we can find any problems with it, and I'll tell you guys what I think about the performance and what I can actually get out of this thing. So, before I screw this clip up, let's get into it. I just started to pull this engine apart while I'm editing some video, and the very first bolt that I pulled out galled and pulled the threads out with it. So this hole here is going to need a Healy coil. That's pretty awesome. I just pulled this exhaust valve off of the KRASH engine and it is in very good shape, which is good news. It also looks surprisingly a lot like a BRP product, so Ski-Doo or Sea-Doo product from the early 2000s. I'm sure somebody who works on those all the time would be able to point out a difference to me, but it has these little guide pins that come off the end. And back in those days, they used the same system with a diaphragm that filled with the gases from the exhaust, and it basically pushed the power valve or exhaust valve open. The more modern Ski-Doos use an actuator motor that is computer controlled, and that's how they do it now. But if you guys know if KRASH actually made these themselves or if they're off of another engine, let me know in the comment section. I've already kind of pointed this out, but I'm definitely not a fan of the way they built this exhaust manifold. They've got slots cut in here so that you can put the bolts in place and then slide the manifold up into place. The trouble with doing it this way is that you've created a funnel. These little slots created a funnel so that anytime water comes in here, it's going to run down into those threads. And in a watercraft engine, that's going to happen a lot. And so, as you will see, these bolts are going to be problematic. It also means that you have a weaker mounting surface in this area, and so you end up with this happening. We have a crack in the manifold here. Fortunately, I have a TIG welder. I assume that this is going to be a real pain in the butt because it's cast. Those two slots that sit in the top of the exhaust mean that the water, any water that comes in, will go down into those slots, and because these bolts probably aren't tightened very well because of their location and the poor access to them, the water will go into the threads and cause corrosion that will cause it to seize up just like they have. So I'm gonna have to do some heating and put some lubricant on there. I've already put some WD-40 on it, so I'm gonna have to leave those sit for a while I tackle some other things. So far, I'm gonna say that I'm not overly impressed with the build of this thing. The next thing that is a stupid design, having countersunk bolts in the top of a head that's going to be running in salt water. The promotional videos and literature on these engines talk about how well thought out they are. And yeah, I don't think it takes a genius to figure out that this is a bad idea. Maybe I'm missing something, but I'm trying to turn the engine over right now, and it's definitely not turning the way that you would expect an engine to turn that has no cylinder head on it. I did get it to move a little bit, but not very much, so I'm going to try to figure out what's going on here. There is a bit of rust in this cylinder. So yeah, I'm gonna have to do a little bit of investigating. I'm gonna pull the carbs off to get them out of the way because they need to be pulled off anyway. These are the intake manifolds, and I have to say they are quite impressive. I definitely have no complaints whatsoever about them, both in the design and the quality. They seem to be machined very well and designed quite well. These are the reeds, which are V-Force 3 reeds. So definitely nothing to complain about there either, except that they're kind of dirty and have like bugs and stuff in them. However, these are the cylinders, and I did a little bit of research on the internet and found out that some of these engines were actually shipped with the wrong reeds. Now, I haven't been able to find out what the wrong reeds actually means, but if you look at these little webs here, you will see that it looks like somebody went at them with a pretty horrid grinding tool. It looks like some sort of finger sander. So this is a finger grinder or a mini belt sander. It's handheld. You can get these in electric, but this is a pneumatic one. And I think this is what they used to do the porting on this, if you can call it that. So I think they basically just went in and did a couple of swipes here and a couple of swipes here, and then repeated that same process over on the other side. This is completely unacceptable, that to make an engine that is supposed to be, you know, above and beyond, and sell them for as much as they do, and then allow that to be in part of your intake tract, that's unacceptable. We'll talk a little bit more about the rest of the porting later on, but for now, that's all I have to say about this. This is purely speculation. I think maybe they were going to put these reeds in, but they either couldn't get these or couldn't get them soon enough. And so they put something else in, and they had to grind away to get the other reeds in. And then, when they finally got these, they had them swapped out. I just removed the stator cover, and this is the mess that's inside there. Not horrible, but it's definitely not good. I'm going to try turning the engine with the flywheel now, or with the flywheel nut bolt, and see what happens. Flywheel moves a little bit. Pistons move a little bit. Crankshaft doesn't seem to want to move very much. The good news is that I got these bolts out, so I don't have to drill them out. They didn't break, fortunately. The bad news is that I'm going to end up putting Healy coils in all of these because I don't trust them as they are. This one for sure has some damaged threads. This one for sure has damaged threads. This one has some threads that got pulled out, so damaged as well. This one has a whole bunch of damaged threads. So I'm just going to Healy coil all of them. I'm ready to pull the cylinder off. I got the bolts out. Once again, they did a really stupid thing and didn't allow for any drainage, so any water, moisture that gets down in there, it can just pool in there. Fortunately, it didn't cause it didn't wreak too much havoc in this area, but I'm probably going to mill these off. I might even mill on the head to allow drainage of water, because that is just stupid. I've finally, after probably 20 minutes of fooling around, got the cylinder to break free. They don't have any pry tabs like most engines have. This manufacturer claims to make a better engine, but so far, other than being big, I don't see, they've copied Bombardier in a few things, so that was smart. But other than being big, I don't see, anything outstanding yet. The porting is pretty decent. I just pulled the cylinders off. They are sitting over there. And quite obviously, this thing had some water in it. I don't know for how long, but it's oily rust, but there's definitely rust on the piston, which means the sleeve has some rust on it. Now that I have the pistons out and cleaned up, I can see that they're definitely not perfect, but they are usable. This is the worst, or the worst looking, I guess. It has a little bit of galling here on the exhaust side, a little bit of scuffing. Obviously not ideal, but I can still see the machining marks near the bottom of the skirt. So although I would prefer not to have it this way, I have been doing some searching to see if I can replace them with something else, and they might actually be the same as a CR500 or similar to that. So Anyway, take a look at the other one. This one is actually in a little bit better condition. This is the exhaust side, which is perfectly fine. The intake side has a couple of grooves, one here and one here. Not sure exactly what happened, but it did get chewed up a little bit, but definitely nothing that would stop me from using this piston. I've now removed this bottom plate, which is strikingly similar to Bombardier. Anyway, I've started to split the cases open with some razor blades, and now I'm able to get a pry in. These areas right here don't have to be sealed, so I'm not worried about prying on them and damaging the sealing surface. In their promotional material for this engine, KRASH does a lot of talk about innovation and why they chose the bore spacing that they did. I'll talk a little bit more about that at the end of this video, but I'd like to say here that KRASH did not design or innovate anything here. These cases are clearly off of some other engine. If you guys know what it is, then let me know in the comments because I'm quite curious. It looks like a Bombardier product, but I can't pick out which one exactly. The reason why I know it wasn't designed by KRASH or that they didn't innovate anything here is because this engine has a water pump drive on it. You can see quite clearly on the center of the case. I've removed the cover, and this was never going to use a water pump. I've discovered pretty quickly that there's a wire going between that connector and something on the lower case, so I actually need to pull the flywheel off and deal with that before I can continue. Fortunately, they just use a standard, I don't know what you'd call it, standard 3-bolt puller, so I will get that now. That was easy. I've removed the flywheel, and this is pretty cool. It's actually a lightweight aluminum flywheel that still has magnets in it and obviously a steel ring gear. I have the scale right here, so I figured I would throw it on and weigh it for you guys, see what it weighs. It is 1,027 grams or 2 pounds, 4.2 ounces. So that is quite light compared to a full steel flywheel. Anyway, it looks like it's made impact with something here before. It's definitely usable, but it's made impact on the inside here and also around this area here. Well, surprise, surprise, I have the crankshaft pulled out, and guess what? We have some bad bearings. So this one on the PTO side does not want to turn at all. I can't turn it by hand. So if you look inside there, you can see it's completely full of rust. I cannot turn that at all. And the one on the mag side isn't much better. It's actually turning. This one is also seized up. I can't turn this one at all. And this one actually seems to be, well, it's not good, but it's not as bad as the rest. These are the crank seals that came off of the PTO side, and as you guys can see, they're pretty nasty. There's a bunch of rust on the spring that holds the seal lip in contact with the crank. And on this one, there is no spring on there for some reason. Maybe that's just the way it comes. And there's a whole bunch of rust around that as well. So the seals need replacing, and a bunch of the bearings need replacing. And to top it all off, the connecting rods, well, they're not much better. This engine did some sitting with moisture inside of it, and it caused, well, for one, the bearings to go bad, but also it caused a little bit of damage to the connecting rods. Now, if this was a JS300 or something like that, I wouldn't be terribly concerned about it, but this thing is throwing around a pretty hefty piston. And because it's a 2-stroke, you use needle bearings in the top end here, and they point load or put a lot more pressure on the surface than you would with a 4-stroke with a pin that didn't use a bearing. So I'm going to be replacing these connecting rods, and so that means I'm going to be doing a complete build on this crank. I'm going to have to rebuild the crank completely. kind of had dead ends with a few things, so I thought I would do some sandblasting on the crash cases. I went to pull out the trigger coil wire, and the seal, whatever, the connector seal that goes into the case here, basically just completely fell apart when I went to pull it out. So I'm not sure what kind of crappy plastic they used there, but it's supposed to have some release tabs on the inside of it. I pushed up on the one release tab and it just completely fell apart. And then I went to twist it from the outside to kind of rock it to see which way it would rather go. Kind of get a feel for it, and the whole thing just popped off. I've sandblasted the cases on this engine. I haven't had time to sandblast anything else, but I thought I would go over it and tell you guys what I think about this engine overall, as far as build quality, technology, and yeah, anything that happens to be a little bit unique about this engine. I've already talked about some of the things that I don't like. This is definitely not a revolutionary engine or something that was changing the world even at the time that it was made. There are a few things that are kind of unique about this, and I'll talk about that in a little bit. But first, I wanted to address some of the things that people talk about. These cases are the castings on crash engines. Some of them apparently had a tendency to be very porous and actually leak. And I think that's why they put the resin in some of these holes. There's actually some resin here and resin in on the water jackets on the case there. And I'm going to be replacing that resin. I'm going to either grind it out or chisel it out or something. I'll be replacing that. But overall, I'm very impressed with the casting quality of the engine. There's nothing, I haven't found anything that I was concerned about as far as porosity. I would say that it's definitely better than the Kawasaki castings that I've seen, and both in finish and just the quality of the casting material itself. So people talk a lot of trash about the crash engines. Maybe other ones are bad, but this one is quite good as far as the quality of the casting. The fact that they put resin in here kind of speaks to the fact that they probably did have some bad castings and they're worried about some of them leaking, so they put that resin in there. Whatever the case, these ones are good. So as far as kind of unique technology, I will go over that because there's only really one thing that's fairly unique to this engine that I haven't seen on a lot of other stuff. And that is the fact that they space the crank webs really far apart. So the distance between the center of this bore and the center of this bore is actually quite far apart. And the reason why they do that is to give a lot larger transfer port volume. On the 1100, I actually have an 1100 cylinder right here, and I'll pull that up to kind of give you guys an example. This is an 1100 cylinder, and as you guys hopefully can see, the distance between the center of this cylinder and the center of this cylinder is a lot closer together. And what that means is that you don't have as much space between the cylinders for transfer ports. One of the limiting factors on an 1100, if you want to go to a big bore kit or if you just start making big power with them, is the transfer ports are just not going to be able to flow enough. So even if you do a bunch of porting on the exhaust and you do a bunch of porting on your cases and your intake and you get that flow all really well, all of your intake charge has to pass through the transfer ports. So no matter how good your reed valves are, no matter how good your carburetors are, no matter how good your case porting is, every bit of your fuel and air transfer has to go through the transfer ports. So you've got your boost port here and then the ports on the side. And this volume is limited because there is a web or space in between the two cylinders. And if you grind through this area, then the charge from this cylinder is going to want to go over here, and that just will not work because of the timing of the transfer charge. What they do on the crash engine is they use a lot more distance between the crank or the cylinder centers, the bore centers. And so if you look at the crank, it's actually fairly unique in that it has this very long section in between the crank webs. So this gives a lot of room to make very large transfer ports. If we take a closer look at the crankcase itself, you can see the volume, the sheer volume of the transfer ports in through the case is pretty massive. This is a huge volume. If we take a look at the cylinders themselves, those are some massive transfer ports. Another thing that's not terribly unique to the KRASH, but I will say they did a good job of doing it, is that they have a substantial amount of cooling in through the bottom of the cylinders. So you can see this is the exhaust port here, and they actually have cooling jackets in through this area. So these are huge cooling jackets around the exhaust. And those cooling jackets actually go down into the cases as well. So the cases have cooling jackets in them. Now we're going to talk a little bit about the porting design. We'll talk about the porting quality a little bit later, but the porting design in this engine is quite good. First thing that I can see is that the exhaust port, I don't know if the camera can pick it up, but it's actually squared off quite well on the top. A lot of OEM cylinders will actually use a fairly rounded exhaust port, and they do that because it's very safe. It won't allow your ring to snag, but it also doesn't work very well for performance. This is the way you want to do it for a performance engine. They also have the extra exhaust ports on the side, which greatly increase your blowdown area. And so I'm not going to get into technical stuff, but that helps get rid of your exhaust charge very quickly in a few degrees of travel of the piston. So that is a nice feature, or a nice design. The intake side of this engine is designed a little bit different from other engines in the way that the reeds are actually mounted on the cylinders, but even though the reeds are mounted on the cylinders, they still intake directly into the crankcase. If you look through the reed opening here, you can see right into the transfer ports. You can see this port goes directly into the case. The piston is actually in there right now and almost all the way to top dead center. So you can see the intake charge still goes directly into the crankcase. So not really any different from it being mounted directly on the cases, just a little bit different way of building the engine. This engine has a huge intake tract volume. I don't see it having any problems whatsoever as far as induction goes. The design of the ports, the layout of everything seems fairly well done. There's lots of cutout on the pistons so that the ports aren't blocked or anything like that. That seems like something that would be fairly obvious, but I've seen on some Kawasaki factory engines that they don't work exactly how you think they would, just from the piston blocking things up. As far as the quality of the ports, I've already mentioned that somebody has hacked away at the intake, and that is definitely going to have to be taken care of. I'm not going to build the engine with that like that, because that's horrible. That's unacceptable. The rest of the porting, the way that it came from the factory, there are some minor casting things. The camera's not going to be able to see most of this, but there are some odd casting imperfections that need to be, sorted out in order to make this engine work optimally. But overall, I have to say, as far as OEM engines go, the port quality on this, the finish of the ports, is actually quite good. It does have stuff like around where the liner goes in here, it could be touched up. There are some casting marks in the transfers. The transfers and all of the ports don't 100% line up with the cylinder sleeve itself, which is extremely common because the two pieces are not really made as one assembly. I will be doing some porting on this, but overall I have to say that I'm pretty impressed with this engine. Oh, these are my connecting rods. OEM cycle. Cool. So these are the connecting rods for the KRASH. That's exciting. I have some stuff coming from WSM as well. Pretty cool. The rods for the KRASH engine are actually the same rods used in the CR500, the Honda CR500 dirt bike. So that is pretty neat. The pistons are almost the same as what is used in a Bombardier 951 or a Sea-Doo 951, except they use a 21mm pin on the Bombardier and only a 20mm pin on the KRASH. So I'm kind of looking through to see if I can find parts so that eventually when it needs parts, I'll be able to get them. This is the mag bearing. It was $94. It's for a Superjet or something like that. And then this one is apparently for Polaris. It is the PTO side. And then these ones are for the center. They are just the... This video is turning out to be a complete mishmash of clips from all different time periods, and this clip is no exception. I'm editing the video and my knee is not doing terribly well today, so I just wanted to jump in here and say that the center bearings fit a whole bunch of different things, including a bunch of Sea-Doos, Ski-Doos, and what I'm most familiar with is actually these bearings are the same as 1100, 900, 750, 800, and 650 crank bearings, so that's pretty convenient. I was able to get all of these bearings without having to get anything KRASH specific. So what are my overall thoughts about this engine? Well, I definitely don't think that it's revolutionary even for the time period that it came out. But I also don't think that it's a complete piece of trash. I can understand some people being frustrated if they got their engine and it came with the wrong reeds in it. I fully understand if you paid a bunch of money for a new machine and the cases were porous and it leaked air. I've heard horror stories about people having a hard time getting warranty and the cases pulling air and the things sticking wide open. Somebody commented below telling me a story about that. Basically the engine ran away on them and it blew up, and yeah, they had to fight for warranty. So anything like that happening, of course, is wrong, and it's going to put a bad taste in people's mouths. So that's just bad customer service, bad marketing, just it's bad overall. If you have a problem like that with your product, you need to take care of it. As far as my specific engine goes, I'm really impressed with the castings. I am really impressed with the overall design and build quality. There are things like the water not being able to drain out of the head bolts, the water not being able to drain out of the where the cylinder bolts go in, and a few other things like that where I look at it and think, you knew this was going to be a marine engine and you still went ahead and did that anyway, so it just leaves me scratching my head. But I'm going to go over this thing with a fine-tooth comb and rebuild it. Quite obviously, I need to rebuild the crank because it's in pretty poor shape. As you guys can see, I've got the pieces for that, and I've also got a hydraulic press. I'm going to do some porting on this engine because why not? I've got it all apart. I may as well do that while I'm in here. And I would say that this thing should have no problem making, say, 130 to 140 horsepower without doing anything real crazy. If for no other reason, it is a 1000cc engine, and even if you're not turning it at a stupid RPM, it's going to develop a substantial amount of torque. I haven't talked about the exhaust or show you guys that in this video, but it's getting long enough, so I'm just going to end it here. If you guys want to support me on Patreon, I have a link in the description below. If you guys have any advice or knowledge about the KRASH engine or stories, I would love to hear that, so be sure to leave that in the comments below. If you guys want to see extras, outtakes, random nonsense, be sure to head over to my secondary channel, which is called Lowered Expectations. Link also in the description below. That is going to do it for this one. Let's hope that the rebuild of the crank on this thing goes well. I will see you guys next time. Thanks for watching. Well, if you stuck around to this point, I guess I'll tell you about my incident on my X2 the other day. Last Wednesday, I went out jet skiing with Dustin. He took his 550 out, and I had my X2 out. I was testing it after changing a bunch of electronic stuff around, trying to diagnose the issue with the CRAT electronics as well as the electronics on my X2. Anyway, we were cruising around. I was acting a fool like I always do, and I decided I was going to rip along the shoreline, and the shoreline at Twin Valley is quite rocky. And so I was keeping a fair distance. I could see how shallow it was. I knew I was being a little bit reckless. And the ski had died a couple times on me, and I had actually run it up onto the beach once because the engine died. I was tearing along the shore, probably going about 50 miles an hour, and it kind of turned, the shoreline turned to the right. So I think what happened is I turned to the right to follow the shoreline. And I remember looking and seeing there was a giant boulder, like I don't know, like 4 or 5 feet by 4 or 5 feet, like a big boulder. And I looked over at it as I was turning and thought, man, if I ran into something like that, would be a very, very bad day. And just as I was thinking that, I think what happened is the engine died on my ski. So I was turning quite aggressively. The engine died and it pitched me over the front. And because it pitched me, I flipped. And the first time I hit the water, I landed on my back and I skipped across the water and continued rolling. And I think I would have got hurt a whole lot worse if I hadn't skipped that first time, because that took off a bunch of speed. So I skipped off the water, and the next time I hit, I was kind of facing the water. And I went into the water the second time, and my leg, pardon me, my knee caught a big rock, probably, I don't know, as big as my upper body or a little bit bigger. So my knee caught a rock on the bottom and twisted it. And the details of exactly what happened are a little bit foggy. I think I was so focused on self-preservation. I get in a lot of accidents and crashes, and I've hurt myself lots on BMX bikes, but for some reason this was a little bit different. I guess I knew that the severity of it could have been really bad, and I was assessing the situation and trying to figure out if I was going to need to rush to the hospital immediately, trying to think about if my ski was going to be okay, how we were going to get back to the vehicles, a bunch of stuff like that. So anyway, it's a little bit fuzzy about exactly what happened, but anyway, it's 4 days later now. It's Sunday, so it happened on Wednesday evening. And I'm able to, I walked around a bit on it yesterday because I had to get my jet ski off the truck and unload a bunch of stuff. So it's not feeling great today. I probably shouldn't have been walking on it yesterday, but I can actually support my full body weight on it, but any kind of twisting motion or anything. So fairly certain that it's tendons or ligaments or something like that are stretched or sprained. But yeah, it seems to be healing fairly quickly if I can just stay off of it for a week. And yeah, that's not going to happen. But if I can take it easy for a week and gradually get back on my feet, it'll probably be okay. Anyway, that is the real end of the video.